This recording is for my grade 11 students. We will talk about using online ticker timer simulation. I currently have inclination angle set at 45 degrees. Frequency of the timer is at 10 Hertz. And I'm going to run the timer. As the cart goes down, the timer makes marks at certain intervals. That's where 10 Hertz come in play. It means the distance between 2 points in terms of time is 1/10 of a second. If I switched it to 50 Hertz, that would be 1/50th of a second. And if I switch to 60 Hertz, that would be 1/60th of a second. It probably means that there will be more frequent dots here, probably more accurate calculations. That's an open-ended question. For now, I'll just stick with 10. To start calculations, I want to do several things. My final goal will be to find position, displacement, velocity, and acceleration of this cart. The only data that's available to me are these dots. So the goal is to learn to use information and then ask yourself different questions. What if I change the angle? What if I change the frequency? Will acceleration change? What if I take dots closer to the end of the journey? Will it be more accurate? Different questions you can ask. The setup that I created is right here. My angle alpha is at 45 degrees. My frequency is at 10 Hertz. That means that the time is 1/10 of a second. So I want to calculate initial and final position, displacement, velocity, and then I will go for acceleration. I'm going to choose 2 dots at the beginning of the journey and find the distance between those 2 dots. Suppose I pick this 2. I need to calculate the difference between them. So I record this into my file, final minus initial, and my result is 0.104 meters. Then I move and choose another 2 dots somewhere further down the road. Let's say here. Maybe just need to zoom in. It's a little bit finicky in terms of adjusting, so you want to see the numbers. So you need to choose appropriate zoom. So suppose these are my next 2 numbers, and I want to calculate the distance here. So position 1, position 2, and displacement. Let's record that in my document. So I record my final to be made out of position at 7,795 to 6,791. The difference is 1.004. So we clearly see the distance between 2 points in the beginning of the journey was small, and later the distance is large. That is understandable because the cart obviously moves with acceleration. So if it was small distance in the beginning and large distance between the 2 points, the cart moves with acceleration, and it's our goal to find out. that number. We can now find out velocity at the beginning of the journey and velocity, I can't say at the end, but where I chose my final points to be by dividing these values over time, remembering that our time is tied to the frequency of the ticker timer, and it is 1/10 of a second. Here are the calculations for it. So displacement in the beginning of the journey, 0.104 divided by 1/10 of a second will give me 1.04. Displacement at the end of the journey, 1.004 meters divided by 1/10 of a second will give me 10.04. So these are my initial and final velocities in the beginning and at the end of the journey. Using the formula for acceleration, final velocity minus initial velocity over the time interval, I will be able to calculate the value for acceleration, but my time interval is no longer 1/10 of a second. I need to count how many 1/10 of a second fits between. So I'll put this letter N here, and then we will count manually how many spaces are between the dots. So if I make a quick drawing to illustrate it, let's say this is our incline and we have dots, 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 dots. I will need to count how many intervals I have. 1, 2, 3, 4, relative to my chosen values. I will show you in a moment on the actual demonstration. This is where I will start counting from 0.034. This was my first point. I need to count the time intervals. This could be difficult because it requires a little of adjustment of the zoom. So from here we start and we go, maybe I will write it on top. 1, 2, 3, 4, 5. Then I move this a little bit. This was 5, 6, 7. This was 7. This is 8, 9, 10. And that's where I think I got lost. So I'll start again. 1, 2, 3. And I need to count up to this value. That's where I will finish counting. I do not need to count the last batch. Kind of from the starting to the starting. So I counted about a couple of times and I got that N is equal to 13. I will make a record of that. And then I will insert my values and calculate the acceleration. So once I put my values in, 13 is the number of time intervals. Each interval is 1/10 of a second. Difference between final and initial velocity is 9 meters. And then here's the secret move. This value, 1/10 of a second. yes, it can be converted to decimal, but for example, for 1/50th or 1/60th of a second, that decimal becomes like so small. Instead, this 10 actually belongs to the numerator, and you can multiply 9 by 10 and then divide by 13. And when you do that, you get 6.92 meters per second squared. And that is the acceleration of the cart that is moving at an angle of 45 degrees. Using the ticker timer that operates at 10 Hertz. Then you can repeat the same using a different angle and see what acceleration you get. Or you can use the same angle, but get a different frequency for the ticker timer and see if you can have the same result. Or you can put your own question. One last comment. So I chose my values to be at the beginning of the journey for the position and displacement, and closer to the end of the journey, those two. The other question you can ask, if you choose two values somewhat close to each other, will you be able to calculate acceleration using values that are somewhat close to each other? Will you get the same value for acceleration if you choose points that are close to each other, rather than when you choose points far apart? So this simulation leaves you with quite a few questions that you can explore, which is what we're going to do. And thank you for watching.